Okay, there we go. Um, so a little housekeeping here for us. As we go through today, feel free to ask questions using the question and answer interface there in Zoom. So don't send it via chat or private message. Use the Q&A or question and answer in the Zoom interface to send it in, and I will do my best to answer it. So today we are talking about Wi-Fi 6E, which is the latest in general standard that's out there right now. It's the latest one to have been ratified for Wi-Fi. So we'll talk a little bit about it. We will also here talk a little bit about Wi-Fi 7 towards the end. And we're going to start though by talking about Wi-Fi 6. So why are we talking about Wi-Fi 6? It's because Wi-Fi 6E is Wi-Fi 6. The E just means extended. So with Wi-Fi 6E, you get to use Wi-Fi 6 on a larger range of frequencies than you would with typical Wi-Fi 6. So Wi-Fi 6 works with 2.4 and 5 gigahertz, whereas Wi-Fi 6E works on 2.4, 5 gigahertz, and the new 6 gigahertz open spectrum that's available for us. And that is something really important here with Wi-Fi 6, just to talk about here, is that Wi-Fi 6 upgrades your 2.4 and your 5 gigahertz radio. With 11AC wave 1 and wave 2, you only upgraded your 5 gigahertz radio. Your 2.4 gigahertz radio continued to operate as an 11N device. So with Wi-Fi 6 and now Wi-Fi 6E, your 2.4 gigahertz radio is basically jumping 2 generations all at once. So you get a big performance improvement for you on 2.4 versus 11AC. So Wi-Fi 6 was designed to solve a lot of the problems that have been plaguing Wi-Fi since the early days. If you've sat through my, hour and a half long Wi-Fi 101 presentation, you'll know the basically the way Wi-Fi was enabled, the way Wi-Fi works. That was all initially defined back in the late 1990s. And really, there haven't been any sort of really significant improvements to Wi-Fi since then, because the standard was originally put together back in a time, before anyone saw Wi-Fi being ubiquitous. Anyone saw Wi-Fi being used to stream HD video content, to do phone calls, to do things like this. The standard wasn't really designed for modern day usage. So Wi-Fi 6 is the first of the main upgrades to Wi-Fi that's specifically been designed to sort of bring Wi-Fi into the new millennium, 20 years late. So basically the old way of doing Wi-Fi was what we would call contention based. Basically, it was a free for all. Clients fought for their airtime, and when they got to transmit data, they stepped on each other's toes, they interfered with each other. So with Wi-Fi 6, it's more contention free. It's been specifically designed to sort of fix all of those old school problems that have been plaguing Wi-Fi ever since. So with Wi-Fi 6, it's up to 40% faster than 11AC. It's been designed specifically for larger capacity. So that means more users per AP. It also means more APs and more users combined together in the same space. So it helps more devices share the same AP. And it's also been designed to reduce the interference between APs and between clients on one AP interfering with clients on another AP. As I mentioned earlier, Wi-Fi 6 improves both the 2.4 and the 5 gigahertz radio. And in theory, your high-end Wi-Fi 6E devices will be marketed as 10 gig on the Wi-Fi side of things, with a theoretical max speed of 9.6 gigabits per second. Now, this is Wi-Fi. And again, if you've sat through my long Wi-Fi 101 webinar, or if you've just been using Wi-Fi, you will know the advertised or claimed theoretical speeds are generally almost double the speeds you see in real life. And that's still going to be largely the case with Wi-Fi 6. So even if you had a 10 gig Wi-Fi 6 access point, you'll probably top out somewhere around 5 gigs of actual throughput if everything is lined up perfectly. And we get into more of that with the Wi-Fi 101 webinar, but just in general, there's a lot of overhead that makes sure your data isn't corrupted and deals with the fact that you're transmitting data in an open RF environment where no licensing is required and all sorts of different devices, not just Wi-Fi devices, are using that same spectrum. So because of that, there's a ton of protocol and other overhead to make sure your data comes through correctly, it doesn't get corrupted, et cetera, as it goes through this, war-torn landscape that is the RF space in 2.4 and 5 gigahertz. So this is just showing you here, sort of the speed increases that you can expect to see going between these different technologies here. So just showing here, maximum theoretical speed. Whoops, don't have my little pointer here. With Wi-Fi 4, aka 11N, the maximum speed was 600 megabits per second, that data rate. With 11AC, it was 6.9, and now with Wi-Fi 6, it's up to 9.6 gigabits per second. So how do we achieve some of these benefits? We increase the number of spatial streams. Again, something else I cover on our Wi-Fi 101 webinar. And we now have the ability to do MU-MIMO, both from the AP to clients. Wayne's asking about 6E. I'll get to 6E here at the end. I promise. We just want to start with 6 because 6E is based on top of 6E, and it's just an extension of 6. But so everything I'm talking about now with Wi-Fi 6 also applies to Wi-Fi 6E because Wi-Fi 6 and 6E are the same. So we now have the ability to send multiple data streams from one AP to the client devices like we did with 11AC, but now we also have the ability for multiple client devices to transmit data to the AP at the same time without interfering with each other. So that's new with Wi-Fi 6 and 6E. We've added OFDMA. Basically, it gives us the ability to better divvy up the available airtime and bandwidth between different users and be able to allocate that based on the demands of the individual client device. And with Wi-Fi 6, this can work in both directions. We have what we call resource unit scheduling. Basically, we can tell client devices basically when they should try to transmit data rather than having them just fight over each other. Higher encoding, basically being able to cram more data into the same amount of radio waves or bandwidth. BSS coloring. So BSS coloring basically helps Wi-Fi 6 devices to be able to ignore transmissions and be able to tell that a transmission coming in isn't intended for that particular AP. So it can ignore that data. And then targeted wake up time, again, ability to better utilize the airtime for connected devices. So we just got a couple things here showing. So here with 11AC, we used OFDM, so we could chunk up the available bandwidth into 20 megahertz chunks. Now with OFDMA, we have the ability to create different chunks of various sizes down all the way to, I think it's 2 megahertz in width. So much better, more effective utilization of the available bandwidth and airtime that's available. BSS coloring allows us, like I said before, to help reduce the interference between different SSID or different APs. So this is showing here sort of the performance improvement we see as we add more users onto an access point. So the top line here, the sort of light orange, that is Wi-Fi 6. The blue line here is 11AC Wave 2. So as you see, this number here, this left axis, this is aggregated throughput. And down here, as we go further and further right, we're adding more and more clients. So what you see here is with Wi-Fi 6, as you add more clients, the aggregated throughput remains essentially flat. Where with 11AC and other older technologies, as you add more clients, the actual aggregated throughput through that AP actually goes down. And that has to do with just the poor, all those problems I talked about earlier, where basically the older versions of Wi-Fi weren't intending for so much demand in the network. And so because of that, there's a lot of inefficiencies that Wi-Fi 6 solves. So because of that, with 11AC, as you add more users, your overall throughput actually goes down because of those interference and other issues that pop up. So this is just showing here as you add users, how much data each one gets. So as you can see here, as you add lots and lots of users, you can get up to 3 times the throughput per client than you would with 11AC Wave 2. Okay, so now guys, here's what you want for Wi-Fi 6E. So what is Wi-Fi 6E? So again, Wi-Fi 6E is just Wi-Fi 6, but we've extended it to be able to also operate in this 6 gigahertz space. So when it comes to broadcasting radio waves, generally, you have to have a license to broadcast radio waves. They are owned by the public. They are managed by the FCC, and the FCC sets the rules for being able to transmit radio waves. So it's no different whether you're running an FM radio station or whether you're trying to broadcast from a little handheld walkie-talkie. Now, obviously, it's not very efficient if home users have to go out and get a license to be able to use their walkie-talkies or their Wi-Fi devices. So the FCC has opened up sections of spectrum that anybody can use as long as they follow the rules, and there's no licenses required. So for Wi-Fi, that has traditionally operated in the 2.4 gigahertz and the 5 gigahertz spectrum that the FCC has opened up for people to use. So not too long ago, the FCC has opened up 6 gigahertz for unlicensed use. So previously, you had to have a license to use 6 gigahertz, which is why Wi-Fi didn't support it. Now that you no longer need a license, we're free to be able to ship Wi-Fi products that support 6 gigahertz, and you're free to be able to use them without needing a license. So that's the key thing here with 6E is now you can use this 6 gigahertz spectrum. So 6 gigahertz basically gives us a lot more capacity. And I'll show you that here on the next slide. And it also gives us what we're calling here no interference, or at least a lot less interference. And there's two reasons for that. The first reason for that is because Wi-Fi 6 gigahertz has historically needed a license. There aren't very many licensed users out there, and outside of Wi-Fi, I don't think there's anything else currently that's using 6 gigahertz. So you're not fighting with a bunch of legacy users and other devices that are already using 6 gigahertz. The other reason for this, and this is something we talk about in that Wi-Fi 101 webinar, is as frequencies increase, the range decreases. So just like 5 gigahertz doesn't have the same coverage as 2.4, 6 gigahertz doesn't have the same range or coverage as 5 gigahertz. So because of that, the signal travels less distance, so there's less chance of getting interference from a neighboring device or user. So here's what we're talking about with the bandwidth here. So this is your 2.4 chunk of spectrum that everybody has to share that uses 2.4 gigahertz. Here's our 5 gigahertz chunk of spectrum that we all get to use. And if you've been doing Wi-Fi for a while, you know that a lot of you will never use this middle section because of interference issues and issues with what's called DFS, dynamic frequency selection. So most of you don't use DFS channels because if people are bringing their own devices from home, their iPhones, things like that, the generally consumer devices generally don't support those middle channels. But even so, if you combine this with the full 5 gigahertz, 6 gigahertz is bigger than those combined. So 6 gigahertz is giving us a ton of spectrum that we're able to then share amongst our users. So to give you an idea here, to get the maximum speeds with 5 gigahertz, you have to use 160 megahertz wide channels. With 5 gigahertz, there's only 2 of those that are available that don't overlap. So if you're maximizing your Wi-Fi speed, as soon as you add a third access point, you have interference issues because you're having to reuse one of those 2 channels. With 6 gigahertz, we now have 7 non-overlapping 160 gigahertz channels. So now you can have 7 APs all operating in the same limited area and not have to worry about interference until you add that 8th AP before you start running into those. And of course, if you're not using 160 gigahertz channels, you run into the same thing here. If you drop back to 80 megahertz channels, right, you're doubling, or you're getting a huge increase here as well compared to 5 gigahertz. So it's going to make things a lot easier for you as far as it dealing with interference issues. So the main benefits of 6E are going to be high density environments, right? Areas where there's a lot of access points in the same area, for instance, high-rise apartment buildings, some of your office buildings where you've got a lot of small offices in them, or areas where you have a high density of users in the same space. So, your expo centers, your lobby and conference rooms and things like that in hotels. So that's one area. The other area where we start to see some benefits has to do with any sort of application that requires a lot of bandwidth. So again, with 5 gigahertz, chances are you weren't using 160 megahertz channels because there were only two available. They only worked in the DFS space, which again, a lot of consumer equipment doesn't support. So for a lot of those reasons, you wouldn't use those. Where now with 6 gigahertz, you've got so much bandwidth available, and by default, every device should support 160 megahertz. You don't have to worry about DFS. So now you're able to maximize and use those full 160 megahertz channels to maximize the bandwidth that's available for you. Dustin has a question here, so I'll go ahead and answer Dustin's question. Speaking of interference issues, will the tri-band radios be more inherent to interference with larger channel lengths communicating in the same space? So I don't think tri-band radios are going to change anything versus dual band radios, because each of the different bands are separate from each other. So you don't have to really worry about a 160 megahertz 5 gigahertz channel interfering with 160 megahertz 6 gigahertz channel. So there's not going to increase the amount of interference there. But yeah, in general, especially on 5 gigahertz, as you're using bigger and bigger channels to get faster and faster speeds, you are going to increase the chances that you're going to overlap with one of your neighbors or some other device that's not Wi-Fi but is still using those same frequencies to cause interference. So yeah, I mean, that is something you see a lot of times. To deal with interference issues is you drop back to smaller channel widths to deal with that. So again, because 6 gigahertz is so open, you can have 7 devices using those 160 megahertz channels without worrying about them interfering with each other. So it's not going to be a big deal today. Maybe 5-6 years down the road, when everybody is supporting 6 gigahertz and everybody's trying to use ridiculous amounts of bandwidth, you may want to then drop back to 80 megahertz channels or something like that. Another area where 6 gigahertz has some potential has to do with wireless backhauls, creating mesh networks. So one of the nice things here, we've seen the push to use mesh, particularly in office buildings, over and over again, and it usually peters out because even with tri-band radio solutions, there's just not enough 5 gigahertz bandwidth available in a dense environment for that to work well. Now, home users, it works okay, and a lot of home, particularly with single family dwellings, a house by itself versus say, a dense apartment building. But in offices, it hasn't really worked. So this may be the exception to that, because with 6 gigahertz, you can use that as your backhaul. You don't have to worry about your clients upgrading to needing to support 6 gigahertz. You continue to let them connect using 2.4 or 5, and then you use this super fast 6 gigahertz radio to create the mesh backhaul back to the wired connection. So that way, I think mesh becomes a much more effective solution in the business space and offices and things like that where it has failed in the past. So this is another area where 6 gigahertz may be something that you'd be looking into. So that's all the good stuff. Let's talk about some of the bad stuff, or at least some of the areas where we've got some concerns or some things that you should be aware of. So before this was opened up to the FCC for everyone to use, this was used by licensed users. Primarily, these were used for smart communication for utilities, and were used by your local news reporter to be able to send video bandwidth back, for live streams and things like that. So those users are still using this spectrum, and they don't like the fact that this has been opened up. So there are lawsuits that I believe are still going between some of these legacy users and the FCC. So now the FCC's solution to this was to create something similar to DFS, but without some of the drawbacks of DFS. And that's called automated frequency control. Now, here's the trick with that. Well, first off, I guess I I got a little ahead of myself there. This is only an issue really for outdoor users. So you don't need automatic frequency control if you're using 6 gigahertz indoors. And the reason for that, again, is 6 gigahertz doesn't penetrate things very well. So you're not going to get a lot of leakage from your building outside. You're not going to get a lot of leakage from legacy outdoor users and their signal bleeding into your house. So it's not a concern. But if you're trying to do Wi-Fi 6E outdoors, you do have to support this automatic frequency control legally. So that's something to keep in mind. And the other thing with this is it's still not officially available for people to use. The FCC late last year um, uh, conditionally approved for basically testing purposes a number of different vendors with automated frequency control applications or solutions. Unfortunately, none of those have been officially approved for commercial use. They are not officially out there for us to use. So at the moment, outdoor Wi-Fi 6E is essentially illegal. So you can't use 6 gigahertz outside. It's purely an indoor solution today. Um, I have seen vendors advertising outdoor 6 gigahertz, and they're not worried about the FCC, or in some cases, some of these vendors, if you want to use 6 gigahertz outdoors, will help get you into a beta test. So we are not doing that. We are waiting for the FCC to officially approve and certify various automated frequency control solutions, and then we will work to integrate with them to work with our access points. So for right now, 6 gigahertz is indoors only. And then again, there's those lawsuits. So who knows if those lawsuits, if they're successful, would block outdoor usage permanently or create additional changes that may need to be made, which is why I think the FCC hasn't actually certified any of these solutions. I think they are waiting for the legal situation to resolve itself. Other trade-offs here, again, like we've talked about here, it's higher frequency, so it means less range. So you will need more access points to cover the same amount of area in 6 gigahertz as you would in 5 gigahertz. There's also lower power limits generally on 6 gigahertz versus 2.4. And then the other thing here is the added cost, right? So you've now got 3 radios, 3 sets of antennas, 3 sets of amplifiers that all your hardware needs. Your hardware also needs a faster, bigger CPU to be able to process and handle the additional users and throughput. So in general, Wi-Fi 6E is going to be more expensive than your traditional Wi-Fi 6 products. Whoops, there we go. So this leads us a little bit here to talk a little bit about Wi-Fi 7. So Wi-Fi 7 up to this point has still not been ratified. This slide says we're expecting a version 1 release in Q4 this year. I don't know if that's still accurate. I think it's been pushed back a bit. It could be wrong. And then there will be a release 2. So this will be similar to 11AC, where there was a wave 1 with a certain set of features and a wave 2 with a different set of features. So any of the products that are hitting the market today or have hit the market are based on this draft 1.0. It is not an official sort of ratified IEEE standard. It's just based on the existing draft. Products you see released next year will be based on the release 1, hopefully. And then after that, you're waiting to 2025 for the full Wi-Fi 7 feature set to come out. So Wi-Fi 7 is basically the replacement for Wi-Fi 6 and Wi-Fi 6E. We will probably have our first Wi-Fi 7 products, hopefully before the end of the year, available for you to purchase. We'll see on that. So Wayne's asking here, the WAX655E is described as an outdoor device, is not 6E. Yes, correct. The WAX655E is purely a Wi-Fi 6 device, not a 6E device. So let's go through the hardware real quick, and then I'll circle back around and talk a little bit more about Wi-Fi 7 here at the end. So here is our Wi-Fi 6E lineup. We've got 3 different access points here for you. The first 2 are something that I think we are the only vendor that is currently doing. Feel free to correct me if I'm wrong on this. We're calling these band flex access points. So this is our way to try to deal with the fact that you've got a lot of expense that goes into being able to support Wi-Fi 6E with the 3 radios. So what we're giving you here is a 2 radio solution. On these 2 models, one radio supports 2.4. One radio can support 5 or 6 gigahertz, but not both at the same time. So that's where the band flex comes in. It allows you to choose what you want to use that second radio for, 5 or 6 gigahertz. So you say, well, why would we want to do that? And the answer to that is because there's not a lot of devices out there that support 6 gigahertz today. So this is giving you a way to easily be able to sort of future-proof your network. You can use these APs for your 5 gigahertz clients today. And once 6 gigahertz support finally hits that sort of mass adoption level, then you can switch those devices over to 6 gigahertz to support those users. So it helps keep the cost down a little bit for you. The other benefit of using these is for those of you that have existing hardware and just want to add 6 gigahertz support in certain areas. Again, the main benefits of 6 gigahertz are either high bandwidth applications or very dense areas. So it may be you don't need 6 gigahertz except for in certain areas where you have those applications. So maybe you're in a hotel, you don't need 6 gigahertz necessarily at your guest rooms, but maybe you want it in the conference room or you want it in the lobby or something like that where you may get more users. You already have APs providing 2.4 and 5. You can buy these, put these into 6 gigahertz mode and add 6 gigahertz support in those specific areas. Anonymous here is asking about the SCR50AXE and Wi-Fi 6. So the SCR50 is not an access point, it is a security router. So it's not part of today's presentation. This is just focusing today on our access point products. But yes, that has a 6 gigahertz rate or a 6 gigahertz supporting radio in it. So that's correct. It is there, but it's not in today's presentation because I'm just talking about our access points. Maybe I can add that for future presentations. And then if you do want, all 3 bands supported today, the WAX640S-6E is our solution for that. So that gives you those 3 radios, all are operating at the same time, and it gets you an aggregated data rate of just under 8 gigabits per second on the wireless side of things here. It has our smart antenna technology built into it, and it uses a multi-gig port for the uplink. So that's it as far as our 6E access points go today. Those are our 3 models. So you say, well, Sean, why don't we have more? What more is coming? And the answer to that is we're not expecting to add any more 6E access points into our portfolio. That may change, but our focus right now is to be able to add Wi-Fi 7 products into that portfolio. And again, I'm hoping that we'll have our first product this year. So Wi-Fi 7 is the replacement for Wi-Fi 6 and 6E. So just like 6E, Wi-Fi 7 supports 2.4, 5 gigahertz, and 6 gigahertz space. The main benefits of Wi-Fi 7 versus, say, Wi-Fi 6E have to do with 2 things that they're able to do. One of them is we have the ability to create ultra wide 360 megahertz channels, so doubling the maximum channel size in Wi-Fi 6 and 6E. So you get really large channels. And because there's limited bandwidth available for that, essentially you're only going to be able to use 3 of those in the 6 gigahertz space before you have interference. They are also adding the ability to create channels between bands. So you'll be able to have a channel set up that covers both 5 and 6 gigahertz. I believe the way to do that on the client side requires that the client have multiple radios, a 5 gigahertz radio and a 6 gigahertz radio to be able to support that. So it's going to probably be a long time before you see that technology supported on the clients anytime soon. There's also some additional technology that goes into allowing access points to coordinate directly with each other for channel utilization. So they can sort of, talk to the other one, say, hey, I need some more bandwidth. Do you got any free that you can let me use type of thing? So, once we start having some Wi-Fi 7 products, we will have a dedicated presentation where we talk about the benefits of Wi-Fi 7 and what's supported. Again, if you remember that slide from earlier, Wi-Fi 7 is coming in 3 waves: the draft wave, release 1 wave, and the release 2 wave in 2025. So there's going to be a lot of changes as far as which features are supported when with Wi-Fi 7. And I'm not currently today fully up on what's coming when and which features are supported today versus later. And again, you run into the same problem we've got now with Wi-Fi 6E, which is there's not a lot of client devices that support 6E today, and it'll probably be a while before client devices support 7. And because it's coming in these waves, it'll be just like 11AC, where some clients will support some features but not other features. And so you'll have to wait for a second or third generation of client device to maybe support the features that you need. And with that, guys, that is the end of the presentation. So again, if you have any questions, use that question and answer interface, send them in. I will answer them for you. Dustin is asking here, do you see market trends killing 2.4 gigahertz, or will it be around forever like fax machines? It will be around forever. Just for backwards compatibility, it doesn't cost that much to add a 2.4 radio into your device. So it's not a big cost factor for you as far as like the access point or a router goes. But on client devices, especially really cheap stuff, you still see them shipping with only 2.4. I mean, it's still pretty much the standard for any sort of smart home device. They all use 2.4, even though something like Wi-Fi 6 would be much better as far as bandwidth utilization and being able to crowd a lot of devices onto an AP, because it's still the cheapest single band solution. So you still see smart home devices just using that. The technology's been around forever. So it's going to get to the point. I mean, I assume at some point someone will phase out, making 2.4 gigahertz chips for those smart plugs, and they'll be forced to upgrade. But there's so many deployed out there, they're going to be around forever. So you're always going to see the access points and routers supporting 2.4 for those legacy devices. I really don't think you have anything to worry about. And one of the nice things is more and more users move to 5 and 6 gigahertz, that's freeing up that 2.4 spectrum and making it less crowded. So it'll perform better for those remaining legacy devices than maybe they get today. I've proposed, this is from Wayne, sorry, question from Wayne. I've proposed WAX 655E plus WAC 650S for a client. Is the WAX 640S-6E a better product? It's not a better product, it's a different product. So the 6E is going to get you the benefit of being able to support 6 gigahertz today. However, the 640S is going to be slower on the 5 gigahertz radio and slower on the 2.4 gigahertz radio than the 650S. So if you're looking for maximum performance on the 5 or the 6 or the 2.4 gigahertz radio, 650S is the faster product there for you. 640S is there because you want that 6 gigahertz support. You want to support 3 bands all at once. Other things with the 650S has got a 5 gig uplink versus a 2.5 on the 640S. So in theory, if you have a very little wireless to wireless traffic and it's all wireless to wired traffic, you would get better throughput on the 650S. And then the 650S also has a dedicated third radio in it that's used for DFS channels to make less disconnections on the 5 gigahertz radio if you're using DFS channels due to the DFS mechanisms. And then also the 650S also supports BLE, Bluetooth Low Energy. So if you're doing those weird sort of multimedia applications with your access point, the 650S offers that as well. So hope that answers the question for you. The key one though is just 650S is going to be faster on 2.4 and 5 gigahertz. 640S gets you tri-band support. So it's just whatever your customer needs today. I'll wait to see if any more questions come in. While we're waiting here, just do point you here, we do have user forums. It's really easy, forum.zyxel.com. I highly suggest you check them out. In addition to a place where you can talk to other Zyxel users, it is monitored by our support and our product management team. You will often see them answering questions there. It is monitored by them for feedback to try to figure out, which features people are looking for and to help prioritize improvements. And probably more importantly, that's usually the first place where security advisories and release notes and things like that are put out there. So it's a great place to keep on top of what's going on from us. Okay, I'm not seeing any more questions, so I'm going to go ahead and end today's webinar. Thank you for showing up, guys. Hope to see you at one of our other webinars.